Here's a problem about a car that is negotiating an unbanked circular turn. So it's going around some circular turn with radius r, and it's unbanked, meaning that the road is flat. It's not at an incline. And we're told that it's going at a speed of 21 meters per second. And the current conditions are the road is dry, and the maximum static frictional force acts on the tires. Of course, that's the reason it's going on a curve, because we know that when you're going on a uniform circular motion, that there has to be centripetal acceleration and centripetal force directed towards the center of that circular motion. So if the curve is this way, that means the center is somewhere around here, and the friction force between the tires and the road is what's driving the car around the turn. This is what's representing the centripetal force in this case. This is what's acting as the centripetal force. And then we're told that suddenly there's a wet patch in the road, and that decreases the maximum static frictional force to 1/3 of its dry road value. So first of all, we know that this was for dry. And then we know that the centripetal force dry compared to the centripetal force wet is now going to be 3 times, because the wet is 1/3 of the dry, so the dry is 3 times the wet. And we're asked to figure out the speed on the wet patch such that the car continues on that circular path. So this is a uniform circular motion question, and I know in that case that the centripetal acceleration is related to the tangential speed in this way, that the centripetal acceleration is v squared over r, and naturally the centripetal force is mass times the acceleration, in this case the centripetal acceleration, so it's mass times v squared over r. So if the mass of the car has not changed and the radius of the curve has not changed, then for a change of the centripetal force, I can calculate a change in the velocity or the tangential speed. Okay, so the force then, when it's dry, is equal to the mass over the radius multiplied by v dry squared. And similarly for wet, I know that the centripetal force wet is equal to the mass over the radius multiplied by v wet squared. So if I know the ratio between these two, then I know the ratio between the v squares. So if I divide this equation by this equation, then I get FC dry over FC wet is equal to m over r v dry squared over m over r v wet squared. And the m over r cancels because that's constant, and I'm left with this relationship. But I know that FC dry over FC wet is equal to 3. So therefore, I know that V wet squared is going to be equal to V dry squared over 3, right? Divide both sides by 3 and multiply both sides by V wet squared. You will get this relationship. So if I substitute 21 in here, then I know that V wet will be equal to 21 meters per second multiplied by 1 over square root of 3, and that's equal to roughly 12 meters per second.